Hello and Assalamualaikum. So my name is Muhammad Khairani bin Ma'arifin. My metric number is 193550. So today I will do the introduction for this lab experiment. So CH3R is the chemical reactor, consists of enclosed volume in which the chemical reaction takes place. In a CH3R, one or more fluid reagents are introduced into a tank reactor, which is typically stressed with an impeller to ensure proper mixing of the reagent while the reactor effluent is removed. For a CH3R, the process condition and input such as stirring speed and flow rate will play a major role that will affect the final product of the composition. This experiment is held to observe the effect of process condition to the final product. So for the theory, for this experiment, NaO and ethyl acetate are used as reactant. Titration is used as mean to determine the concentration of the analyte with phenolphthalein as the indicator. Multiple stirring speed and flow rate are used as the variable to observe the changes of the final product. And the reaction takes place is illustrated below, which is an ester react with a base to form a carboxylic salt and an alcohol. So that's all from me.
Okay, so I'm going to explain about result and discussion. The saponification is a process where produce soup in the presence of aqueous alkali. Okay, in this experiment, we done two parts. Where the first part is we varies the time intervals, and our group choose to use 5, 10, 15 and 20 minutes as our time interval. Okay, the reactant uses ethyl acetate and sodium hydroxide, where both with concentration of 0.05 molar. For the titration sodium hydroxide, the concentration used is 0.1 molar, and for the quenching, which is hydrochloric acid, we use concentration of 0.25 molar, and the sample taken from the reactor is 50 ml. Okay, the first graph shown here is volume of sodium hydroxide needed for the neutralization, and the second table is the concentration and mole fraction of reacted and unreacted sodium hydroxide with ethyl acetate. Okay, as you can see that from the first table, the volume of quenching unreacted in the sample for 5, 10, 15 and 20 minutes is 3.6 ml, 4.44 ml, 4.36 ml and 4.68 ml respectively. And we can also saw that the volume of quenching reacted in the sample is 6.4 ml for 5 minutes, 5.56 for 10 minutes, 5.64 ml for 15 minutes and 5.32 ml for 20 minutes. And the volume of titration with sodium hydroxide used is 9 ml for 5 minutes, 11.1 ml for 10 minutes, 10.9 ml for 15 minutes and 11.7 ml for 20 minutes. From that, we can conclude that the higher concentration of hydrochloric acid, the higher the volume of sodium hydroxide needed for the neutralization. For the second part is where we vary the mixing speed. Okay, and based on the second part calculation, it is fitted to state that the reaction is second order. Since straight line is obtained when we plotted the graph of 1/A versus time. The table shown is for the speed of 2 rpm, where the first table here is for the volume of sodium hydroxide needed for the neutralization, and the second table is for the concentration and mole fraction of reacted and unreacted sodium hydroxide with ethyl acetate. In this part, we use the second table from the concentration of sodium hydroxide unreacted with ethyl acetate to plot the graph, and from that we obtain the reaction rate constant for 2 rpm is 30.4386 liter per mole, and for the speed of 4 rpm, table shown here is for the volume of sodium hydroxide needed for the neutralization. Next, the table shown here is for the concentration and mole fraction of reacted and unreacted sodium hydroxide with ethyl acetate, and where the second table is used to plot the graph 2, where the concentration of sodium hydroxide unreacted with ethyl acetate is used to plot the graph, and from that we obtain the reaction rate constant of 34.1619 liter per mole. And lastly, for the speed of 6 rpm, here the first table of the volume of sodium hydroxide needed for the neutralization, and here is the second table for the concentration and mole fraction of reacted and unreacted sodium hydroxide with ethyl acetate. Same as the speed of 2 and 4 rpm, the second table is used for plotting the graph of 1/CA versus time, and from the graph plotted, we obtain the reaction rate constant for 6 rpm is 39.5075 liter per mole, where we can conclude that the higher the mixing speed, the higher the reaction rate constant obtained.
In the conclusion, the saponification reaction in the stirred tank reactor takes time for the reactants to react together at a given velocity to form the salts, which is the product. The longer the saponification process takes, the more reactants can transform to form the salts. For the fixed reaction rate, which is the K, the reaction rate constant value for the stir of 2 rpm, 4 rpm and 6 rpm is 30.439, 34.162 and 29.507 liter mole minute. From this observation, the higher the velocity of the stir mixing, the higher the constant reaction rate, which is K. For our recommendation, for a good mixing to happen is to have a large stirrer in the CSTR vessel, so that the chemicals in the vessel have high rate of mixing, and a good condition of plant can achieve a faster rate of mixing in the vessel. That's all for us. Thank you.